I myself, Dr. Sridhar K.S., presently working as a professor in the Department of Computer Science and Engineering, University BDT College of Engineering, Davangere. Let us understand one of the subject, programming in C and data structure. This is a very interesting subject to everyone because everywhere you go, computers are essential today. Let us understand what is a computer. A computer is a device capable of performing computations and making logical decision. That is how it differentiates from whatever you are having, a calculator and a computer. So whereas in the computer you are having logical decision making system also. Computers process the data under the control of set of instruction called computer programs. Hence, writing the set of instruction is what you are going to learn in this subject. That is what programming means. So it consists of hardware and software are the two parts whenever you see a computer. The physical component, what we call it as a hardware, something you cannot see, that is what the software. The program that what you are going to see, write is what we call it as a software. The hardware consists of so many components such as the keyboard, the screen, the mouse, the disk, the memory devices, CD-ROM and processing units, motherboards are all examples of related to the hardware component of a computer system. So let us understand how this looks. If you see this pictorial diagram, all of you can see all the components are embedded. Usually we call it a central processing unit or a CPU, a box. And the floppy disk, the CD-ROM and the monitor, these are all embedded to form as a computer. So we will look very detailed what is going on inside. The CPU play an important just like a human beings. We are also, the head is responsible, the brain is responsible for all of us to take any logical decision or computation that will be taken place. Similar to that, in this computer also you are having a central processing unit, that is what we call it as a CPU, a rectangular box it is shown, where the control units, the arithmetic and logical unit, the register storage area, these are all forms the internal component of a CPU. Along with it is associated with a memory that is called primary storage. It is along with this you require the input data to be taken from the input devices, and then you have to communicate with the external devices such as the modem, or through the internet you require a communication devices, and some of the things you should be get displayed or printed in a hard copy document, then you require the output devices. Along with this, many times you require many external information that to be taken. It is not sufficient if we have only the primary memory, then we will connect the secondary storage. In this way, the internal component that can be observed like this. So how this computer works? There are two phases, instruction phase and execution phase. In the instruction phase, it fetches the instruction one by one from the memory and decodes it because it has to understand what is that instruction. Usually these instructions are written in a higher level languages. Computer cannot understand because it is a machine. So you have to decode it to make it to understand by the computer. And the second phase, what we call it as execution phase, make that instruction to be executed as per the rules you have given and store the result in output devices. So now the question is how to write that instruction. That's all you learn in this subject. That is what we require, a programming language to communicate with a machine. So there are varieties of programming languages are there in the system. That is what the machine can directly understand, that is called machine language, where we are going to write machine specific instruction. Nothing but these instructions are written in a machine readable form. It is difficult for all the user to write the instruction in machine readable form. For that reason, people will go for writing in assembly language, where each and every instruction is associated with a mnemonic codes. For example, if you observe load A refers to storing the data in the A variable, add A, B, C, that means to say add the content of A register, B register, store the result in C, and whatever the result is computed, store into the R. This is how each and every instruction is associated with the mnemonic codes that we usually called as an assembler. That is also difficult for many people to write the program. Hence, we will go for writing a high level language like similar to an English like sentence if it is there, then it will be comfortable to everybody to write a programs. So here we will use some mathematical notation along with the English word so that everyone can write the instruction easily. Example, you observe total salary is equal to basic plus DA plus HRA. If you observe this, there are three data you are going to add and put into the result total salary. This is a very comfortable English like sentence, anybody can write the instruction. In this way, you will write, let us understand what is the meaning of high level means. It is a relative term. C language that what you are going to study is both low level and as well as high level, because it supports assembly language coding and as well as high level English like sentence can also be framed out. There are some previous languages before the C was coming to the market. There are Pascal, Fortran, COBOL. This Fortran stands for formula translation. COBOL, common business oriented language, are the typical high level languages which were there. And later, nowadays we are observing Java, Python, Perl, Visual Basic are the examples of high level languages. So there are some languages which are popular. They are all application specific languages, usually called as MATLAB, JavaScript, VB scripts. They are all comes under the application oriented. So in this way, let us move our journey to understand as per the syllabus which is present in the VTU format. In the module 1, you are going to study what is programming means, pseudocode, how this C has developed from the day 1 to today, history of C, standards, what is the standard to be followed, the basic structure of a C program, how to compile this model, and basic data that what you are going to use in programming, like that related operators, and let us understand some of the example through which let us write the program. This is covered in module 1. In module 2, we are going to make use of the branching statements to write the instruction, such as simple if statement, if then else statement, and switch statement. And in the looping chapter, we are going to study how to make some of the instruction to become continuously repeated with the help of while loop, do loop, for loop, and taking the control without any condition using goto statement, and some example related to this chapter. In this way, let us begin our journey in understanding all these things. The first question which comes to everybody, whether I can write a program. What is programming? That is the question will come to picture. Is it a formal language for describing a computation? Is it a user interface to a computer? Or it is a mix of a syntax or a semantics? Is it a compiler or an interpreter or a translator? These are all some technical terms which will confuse us, but is it a tool to write a programming process? So in this way, let us journey. Loudon is a very famous scientist of our computer science. He describes like this: a programming language is a notational system for describing computation in a machine readable and human readable form. So in this way, a programming is a tool for describing executable models for a class of problem domain. So anybody can write the programming if we have some vocabulary of a grammatical rules that can be formed at the type of writing the instruction as per the language specific task. For example, BASIC supports the instruction writing in its own format. C, C++, like that, every language is having its own set of sequence of well-defined instruction through which we will try to solve our problem by writing the instruction and making it to get executed in the program. So how this architecture or the day 1 from which it was started? Computers are based on one of the concept which is given by von Neumann, and this concept what he given is stored program concept. And here he uses one interesting unit, that is what we call it as CPU, main memory, input output device, and the ports to communicate between the devices, and the set of wires usually called as buses. And using this, it is possible to develop a machine which can work like a human being, so that when a computers are get designed, the action performed by CPU are written through a program. Hence, program is a sequence of instruction. Writing the instruction is the art. As you observed, CPU takes this instruction, that is called fetching, and execute this instruction is the second step. And while doing each and every instruction, it does arithmetic operation, logical operation on the data and gives the output. The whole process goes through our memory system to take the instruction and as well as to store the information. There are two types of memories are usually come into the picture. They are usually called as random access memory. Another one is called as RAM. Let us understand this little bit on all these things as I given. The instruction phase, fetching the instruction, decode. Execution phase, execute the instruction and store the result. So these two phases are continuously done with the help of inside the CPU a unit called arithmetic and logic unit, the register inside and the memory which is responsible for giving that information to the CPU and making it to happen. So RAM is usually called as read only memory. It is permanently stored informations are there in the RAM, whereas RAM is a volatile. Whenever the power goes, the information stored inside also goes out. This is how secondary storages are used to store bulk amount of data. Example for this one is the CD, DVDs, and the capacity of the secondary storages are usually given in megabytes, gigabit and terabytes. Let us understand these with a pictorial diagram, the classification of these memory types. Usually it is divided into two categories. One it is called volatile, that is understood RAM, and varieties of RAMs are there: SDRAM, DRAM, EDORAM. The SDRAM refers to the static RAM, whereas DRAM is a dynamic random access memory. EDO stands for extended data output RAM. So PRAM is what we call it as programmable read only memory. We can change the settings and make it to happen. That's why the word programmable is attached. Whatever it is stored inside the RAM, we can also erase and you can store the new one. That's why the word we call it as EPROM, erasable programmable read only memory. This is how the classification of the memory takes place. So now how this information is stored. It is what we understood in our lower education, the binary system. Even today the information is stored in the memory is stored in the form of a bits. What is one bit? One bit refers to one binary number, whether it may be 0 or 1. So using one bit you can represent two numbers, that is 0 or 1. Using 2 bits it is possible for you to represent 4 numbers, that is 0 0, 0 1, 1 0, 1 1. Like that we can represent 4. Use 4 such bits usually called as a nibble. 8 bits forms 1 byte. A character, for example, when you press A character or B character inside the memory system, it is stored in one of the representation scheme that is usually called as ASCII, ASCII, that is American Standard Code for Information Interchange. This is the universally accepted code representation for storing a character in the memory. You require minimum 1 byte to represent this data. So here in this table, let us understand, using 1 byte, one character that can be represented, 1 kilobyte refers to 1024. And it is usually approximately half page of information that can be stored using 1 kilobytes of memory. So if you use, that is 1024 refers to 2 to the power of 10. 2 to the power of 20 refers to 1 megabytes of information. 1 gigabytes refers to the 2 to the power of 30. 1 terabytes refers to the 2 to the power of 40. Like that, 5 billions of pages that can be stored in 1 terabytes of information. It is just a basic idea how these memory systems are arranged in our system. Let us understand RAM is a very essential component inside our computer system, usually called as random access memory. It is a type of memory that can access faster than the main memory, but only stores the data. Whenever the power goes, the information stored inside the RAM also goes out. That's why RAM is. And another interesting memory that we usually use, what we call it as bulk information that is stored in a device that is usually called hard disk. Well, in the hard disk, these are all some of the important characteristics that should be observed. One is the speed, and second character is how much it can store, that is the capacity, and what is the cost. These are all the factors which makes what type of hard disk, what capacity of hard disk that can be purchased for your system. So when you see this picture, you can see all these components are observed here: the motherboard, CPU, keyboard, the mouse, RAM, monitor, floppy drive, CD-ROM drive, hard disk drive, and as well as DVD drives. So these are all essential hardware component in any computer system. You will always be having the curiosity about where this CPU is placed inside the computer system. There is a printed circuit board that is usually called as a motherboard, where the CPU is placed inside the motherboard, and other devices which are connected to this motherboard through the ports. It is just a layout that can be observed in the pictorial diagram, connections which are established from various other devices to the computer. If you take the photography of this, it looks like this. So many devices, electronic component are placed inside this PCB, and this acts as where the motherboard is also placed here, so that one it starts taking the instruction and executes. All credit goes to one of the famous person in our computer science called Charles Babbage, a visionary who was the first to design computer that would perform multi-step operations automatically. Because of this vision, now we are having varieties of computers which are all available. And another interesting person in our computer science is the John von Neumann, considered to be the father of modern computer architecture. He given the idea of stored program concept. All your instructions are stored in the memory, and each instructions are taken one after the other by the CPU and get executed, and the results are stored in given to the output. This process is given by von Neumann, and this architecture can be observed with the block diagram. If you observe this main memory where your data and programs are stored, each instruction which will be taken by the CPU. Inside the CPU you are having program control and process the data, and communication will be established between the external devices. So this is the architecture what von Neumann architecture is given. So these are all something about related to some of the things which is essential to understand this subject, which what we have understood now. Let us move on to our one of the, so how to write an instruction. Is it so easier or is it a difficult one? To make anything possible, the pseudocode is an interesting thing. Instead of writing the instruction directly in the corresponding language, is it possible to write the instruction like using an English like sentences? So each programming languages uses its own syntax, its own methodology to write the instruction, whereas a pseudocode helps this problem by writing instruction in the basic English phrases that are universally understood. It is defined like this: pseudocode is an informal program description that does not contain code syntax or underlying technology consideration. It summarizes a program steps or the flow, and that excludes underlying details which are required for it. By describing the program in a pseudocode, a programmer can write the program easily and effectively. That's why let us understand a simple example how to write a pseudocode. You want to declare the student result based on the marks. You will write the pseudocode like, if student marks is greater than or equal to 35, print pass, else you print fail. If you observe this is the condition which is required to be get passed, otherwise fail. Before this instruction we will take the marks. If marks is greater than 35, it prints pass, otherwise fail. Anybody can understand this type of instruction. That's why it is called as a pseudocode. So algorithm is also similar to the pseudocode, where we try to use its own notational system so that anybody can easily convert into a form of a program. It is an effective step-by-step procedure to perform the solution to a given problem. It can be expressed using a notation which are required for it. A natural language like English is used to write these steps. So is it any other method through which you can also write this instruction? The another method is there, that is called flowchart. It is a graphical way of representing. It is a diagrammatical way showing the sequence of activities to be performed for a solution to a problem. There are specific symbols which are used in order to show the flow, and as well as the computation. The flowchart and pseudocode are the algorithmical way of representing the instruction makes to write your program easier and effective. Let us understand some of the flowchart symbols that helps in writing the instruction. An organized it consists of so many shapes, lines, textual information inside the symbols are written. So pictorial representation showing all these steps make the flowchart a more effective way. So the first symbol, let us understand, the usually called as a process symbol. It looks like a rectangle box. Inside this box you are going to write the steps that to be followed, or the computation or the calculation that to be followed. Only for the calculation purpose we will use this symbol, that is called process symbol. The next symbol that is very essential is taking the data and printing the output onto the screen, for which you are going to use a symbol parallelogram. If you observe this, if you write a parallelogram symbol indicates the content inside is reading and as well as writing information are stored in this type of this. So another usual symbol that is required is decision making symbol. For example, in the previous pseudocode you observed, if marks greater than 35, pass or fail. In order to show this decision making support, you are going to use a rhombus like symbol. The control comes from the top and decision will be done. If it is yes, it goes in one direction. If it is no, it goes in another direction. So the decision support symbol is shown with a representation. This is summarization of all these symbols. The arrow mark, this is start and stop symbol, that is oval like symbol. Parallelogram symbol for input output, rectangular symbol for processing or a calculation to be done, decision making symbol. These are all some of the symbols. Other than this one, the connector, a circle like symbol connecting two or more process output into a single unit. And if you have filled up with the off page, you want to continue in the next page, you can use this symbol. You have any other external routines here written, you can take that block here like that. These are all some basic symbol which are essential. Let us write one simple flowchart in writing using these symbols. You observe this, the control comes from the top. If the condition is true, there are two possibilities, it may be yes or it may be no. If it is yes, go to the process 1. If it is no, do the process number 2. After doing, connect this with a connector symbol and continue the process. It is a graphical representation of flow of information. That's why flowchart is a easier way of understanding and as well as writing. So another one is, you observe this flowchart here, if the condition is true, it will do process step, and once again this arrow mark says to go back and repeat this process until the condition is true. If the condition is false, automatically it goes to the no part and comes out of the loop. So this is for repetition process. You can show with this diagram like that, the diagrammatical way of representing easier for us to understand. Let us understand with a small example a pseudocode and as well as a flowchart for an example. Determine the average grade of a class. Each student will take a grade. Let us ask from each student and calculate the average of all the students' grade marks. What you require? Initialize a counter and as well as a sum, two variable. Initialize these two variable to 0. Number of students is 0 initially and the sum of all these grades are also 0. That is initialization step. Observe this, do while there are no more data, repeat this process. All these three steps are loop back. Get the grade of the first one, add the grade to the sum. Initially it is 0, now grade is added, 0 plus whatever the grade of that one is 6. Increment the counter because you want to know how many students you want to take it. Repeat this step until all the students' grades are over. After, if there is no data is there, it will automatically comes out of the loop and calculates the average. Average is equal to sum divided by counter. Counter gives the number of students, sum gives sum of all the grades, and finally you are going to display average. If you observe this statement, this is an English like sentences, helps you to understand how to write an instructions. So same thing, let us write it using a flowchart. First one, the oval symbol, start, because all flowchart starts with a start. Initialization, because I am going to use a calculation, that's why use a rectangular box. Initialize counter and as well as sum to the 0. is there any data? If it is there, get that data, that is reading the grade, increment the counter, add to sum and go back once again to read the next data. Read the next data and increment the counter, add to the sum. At each time if you observe, the value of the sum is increased by the new grade. In this way all your sum is get added and the result is available in the sum. When there is no data, automatically the control comes out of this loop and calculates the average, which is equal to sum divided by counter. You got your result in the variable average. Display the average or print the average. This is a parallelogram symbol is used here to display the result and stop your process because you completed your task using stop symbol. Start symbol, stop symbol is same, displaying and reading is same, and calculation is rectangular parts, decision symbol is rhombus symbol. Using these essential symbol and the arrow mark shows the flow of control after each step. Make your steps are clear in writing any flow chart. So let us move on to an example how when you go to the lab, you will start with turn on the computer and then log on to the network and then login is okay. Then we will process it, start your doing your application. If it is no, then what you will do, you will retry once again. Then if it is possible, then you will start your application. Then if it is not possible, then usually notify this to a system administrator. So this is a graphical way how the process going on in your lab. In the same process, a flow chart helps in understand writing the step by step solution to a problem. Let us understand our C programming now. Using this basic flowchart and algorithm, you can write a program in a very interesting language developed by Ritchie. All credit goes to the Ritchie who developed this. The C programming language was designed by Dennis Ritchie at Bell Laboratories in the early 1970s. This language is influenced by ALGOL in 1960. ALGOL is an algorithmical oriented language. A CPL in 1963, another language. The improved version of CPL is BCPL, that is Basic Combined Programming Language in 1967 by Martin Richard, and later it is improved by Ken Thompson and he named that language as a B language. The improved version of the B language given by Ritchie and that language is named as C. You are having A, B, C. That's how the language is named with the word character C. So how to do C is a general purpose. For all purpose you will write this, use this language to write the program. That's why the word general purpose language, which has been closely associated with one of the operating system or a system software which is essential for any computer to be run, that is Unix operating system for which it was developed. Now it is almost many of the applications people start using writing the programming in C and it is available in the market. So the standards which are given by ANSI, that is American National Standard Institute, has given a standard in 1989 known as ANSI, American National Standard Institute. ANSI standard was proposed. International standard ISO in 1990 adopted the ANSI and renamed it to C89. And later it was evolved in the evolution process. The standard was updated in 1995 and called C95, and later in 1999 still improved version is given, that is C99. This is how the standards of C is available today in the market. Some facts about C. C was invented to write operating system called Unix. The language was formalized by American National Standard, that's why it is ANSI standard in 1988. And Unix is written completely, Unix operating is written completely using a language like C. C is widely used to develop system software and some of the application softwares also. C is case sensitive program. That means even a capital letter and a small letter it differentiate. It will not take it as same. That's why it is case sensitive. Let us understand some characteristics which are there in the C language. It is a low level as well as high level language. That's how you put this word. it direct accessible to the memory layout through the pointer manipulation. The concise syntax is there. It is a block structured language, and the structural way you can write the program, and encapsulation is also possible through via function, and type checking is a portable. All these are all the technical terms we will try to understand in the coming hours. These characteristics one by one and make this language very popular language among the industry. So how this compilation, as you understood, I have written in a programs in a higher level language where computer cannot understand higher level language because it is a machine. Your language should be converted into a machine language. That process is called compilation. Our compilers will does this. That is, source program written in a language, a source code is pre-processed and then moved to the assembly code, and then finally the object code is get generated. The object code is linked with the libraries which are essential for your program to be run, and finally the executable code is get generated, and the executable code comes out with results. So this compilation model is supported in C language to make your program to be run. Whenever you go to the laboratory, if you use Unix operating system, after typing your first program, at the prompt you have to use cc and whatever the name of the program .c extension, say it is a C program. When you type this program, your programming is get compiled and generates the output in one of the file that is called a.out. For all the program it generates a.out. If you want to differentiate a separate output file for every of your program, then you have to change cc program.c, your name of your .c, with extension -o. Here you type whatever the type of output file you want to be required. In this way you can change a.out to some other file. Otherwise you use cc program.c in the Unix environment. What I observed in many of the system, you will use the Turbo C well known editor and as well as the compiler to write all our C program. Here whenever you click Turbo C, you will get the first screen in this fashion. There is a menu on the top: File, Edit, Search, Run, Compile, Debug, Project, Option, Window, Help on the top. Here we will always use the first one, the File, Compile, Run. These three are very essential for the initial programmer to do all their program. When you click File, we will get the submenu with Option New. When you click this, the first program that will be opens with a heading no name.c or cpp. With usually it is a C++ editor, that's why it is named as cpp, and some of the editor where you can also type it as .c. So C or cpp, it will run your program. So whenever you click, when you type this program, example I had given, that is always it start with #include stdio dot. Let us understand this programming principle in the coming class. But whereas when you type all this program, then in order to compile, we are going to make use of in the top compile menu. So that when you click on this compile menu, it will just gives the error. If there is no error, it will generate a success. You want to see your output, then you have to run your command by making use of run button and run this. Short form also you can use. Instead of using the mouse to go to that position, you can also use Control F9 to do all these programs. So the Control F9 helps and generate the output hello world. So these are the three steps that should be followed in order to make your program to be run at every stage. So when you observe while writing in your program, the first statement in the program is /include. That is called preprocessor directive statements. That is all programs requires this preprocessive statements where the include files are included. A directive statement is associated with a symbol hash symbol. The preprocessor works in a very crude, that is word processor way, simply cutting and pasting and making it to make your program to be run. So your source file, the preprocessor, and enhanced output is get compiled and your object code is get generated. So the general structure of a C program looks like this. A preprocessor or a directive statement with always a statement include. Your program starts with always with a keyword main associated with a return type. Usually it is called data type. It may be there or it may not be there. When you are not returning anything, you are going to use a keyword that is called void, void. Otherwise we will use int. So the main is associated with left bracket and close bracket, and then it starts with the first symbol, that is first left flower bracket. All your statement, the declaration statement, executable statement and return 0. These different types of these statements are embedded between the begin and end, make your program journey of writing the program starts. Observe this, all declarations will be done initially and executable statements are done next, and the last statement is return with 0. Here 0 refers to if it is returning any value, the integer value, we will use it. If you are not returning anything, then we are going to use void as the keyword. So using this minimum structural C program, you can write any program of your choice. So this is the first program you are writing with, observe this, include stdio.h. The stdio.h is the pre-processive directive statement, that is standard input output header file. All your input output statements are included in this header file, hence all your program should be included with one of the pre-processive statement, that is stdio.h, and your program should start with int main with flower. So colored in such a way that when these are all the keywords which are present, they are main is a keyword, printf, that is whatever the content you want to print on the output screen are put in the double quotes, hello C world, and return with 0. So this is how you are going to write. The output is written here hello C, whatever it is typed inside the flower bracket is get displayed onto the output screen. So this is how the first program that you can write on your keyboard. So header files play an important role. The files that are specified in the include section is called as an header file. So let us write one program, starting program, that whatever written once again. All your program starts with the hash symbol with include left bar greater than symbol stdio.h, greater than symbol, less than greater than symbol, that header files are get included, and this is called pre-processive directive statement. The next statement is the main, open bracket, close bracket, and your program starts with left flower bracket. Whatever you want to print on the output, you are going to make use of a statement printf, and open the bracket. The message that you are going to print on the output is put on the double quote, hello. Close this, put a semicolon, return 0, semicolon. So because you are returning a 0, the main is also acts as a function. It should be associated with the keyword int, because it is an integer returning. That's why you are going to give the return data type as int. When you close this program with a right flower bracket. So this is how your first program looks. When you type this program, you press control key. If you are working in the Turbo C environment, you press control key and then F9 key. That is the function key which is there on the top. Then in the output, we will get hello. To see this result, you have to press Alt key which is present on the keyboard, and then F5 key. When you press this, you can see this result on the computer screen. If you don't want this to be done, then you can use one of the interesting statement. in the program, that is get ch. If you use this statement, you need not to type this output key so that when it get displayed immediately onto the computer screen. When you press any key, it will go out of the output screen, come back once again to the program. So this is how we can introduce one of the function get ch. This is not included in stdio.h. You have to include one more file that is called conio.h. conio.h. Conio, console input output header file. So here you have written first program with the basic header files which is required in all your program. The main as the keyword and simple printf statement to print your output. Get ch to make your result to be seen, it is not necessary. If you want to avoid this alt F5, you can make use of get ch. Until you press a character, it will be get result and written with 0. And this is how your journey of writing a program starts. So the header files which are essential for all the program, these are all called header files. The files that are specified in the include section is called header file. These are pre-compiled files that has some functional defined in them. For example, in stdio.h, this printf, to read the data you are having scanf statement, they are all written inside the standard input output header file. So here also used one function get ch, this is included in conio.h. Hence these are all the pre-compiled files that has some functions defined in them. We can use in your program if we include those statements. We can call those function in our program by supplying the parameters which are required. All header files with a extension .h. All your programs with a extension .c. So that is how your program or the header files which looks in your system. So main is the first statement. This is an entry point to your program, just like begin your program journey with a main statement. This is an entry point of a program. When a file is get executed, the start point is the main function. From main function, the remaining flow starts. Flow goes as per the instruction that you are going to give. In the next instruction you are given is to print the statement which is there in the printf. So hence from main function the flow goes as per the choice. There may or may not be other function written by the user in a program. Main function is a compulsory for all the C program whenever you write it. So observe this, main is always the first function called as a program execution with a statement int main. Inside the main sometime we will not give a parameter, or even if you give a parameter void refers to there is no parameter. So void indicates that the function takes no arguments, no parameters. Always will say it associate with a data type int, return data type as int. What for it is? It indicates that the function returns an integer value. Integer value is not the program just printing out the stuff whatever you have written. It should also returning with a nicely or badly. Your operating system can record accordingly and work with a clear cut picture. For that reason we are going to use the return statement. So whenever you want to write any comments in the programming, you are going to use the comment lines which are required. The comment lines are associated with hash. 2 slash symbols indicate that this line is a comment. Whatever you type, this first program indicates that this line will not be taken by the compiler. It indicates is a comment line. Termination of a comment is by pressing enter key. After typing this, if you press, this line will be taken as a comment. You want a group of statement that should be blocked, then you are going to make use of a slash with a star and type any number of statement, end with a star with a slash, indicates all these lines are referred to comments. So this statement is only for the user or a programmer to understand, it is not for the compiler to take it. So this is the comments line to be understood. You observed in all your program there is a statement called printf, that is nothing but printing your output onto the screen. That's why it is called output function. In the printf function, if you observe, the double quote is there. Within this there are some statements are present. There is a message. In coming program you can also observe some of the control strings which are required to be specified in the double quote. The variables whatever say we are going to use input is get printed in this position. So the printf is a library function declared in the standard input output header file with a format, the format string and any number of expressions that can be encountered. The format string is nothing but string of text to be printed, the original input, printf hello. These are all whatever hello is there in the double quote is get printed onto the output. There are many number of variables whatever you are going to print is comes under the expert values to be printed. So here when you are going to print so many variables in your program, you may notice the variables may be integer, the data what you are going to get is an integer data or a floating data or a character data or a group of character, a name like data. All these things are of varieties of representation. For this you require a specific way of holding this in a control string. We are going to use %s, observe this, input. Here print the strings to be printed, we will use %s, %c for printing only a single character, %d to print an integer, %f to print a floating point. Will come up. You just remember these four: s for string, c for character, d for integer, f for float. If you remember these four control string, you can write your program easily and more effectively. In all these programs there is an indicator /n, indicates that it is a new line character. It is a new line character through which after typing this your control goes to the next line. So the next, it is a simple example to demonstrate in front of you how to read a number. Include stdio.h, it is same as your previous program. Int main begin flower bracket. Here there is a small change from your previous program to this program. Here along with the string, whatever the number is there, the number is also printing. That number you assigned in your statement, a number is an integer type, int is a keyword, space number assigned with 10. So number is assigned with a value 10, that is get printed %d position. The value of this one will be get printed and return 0. The same program with a small change. When you output comes in your screen will be number is 10. Because number is the message, %d position, the value of this number whatever is assigned in the previous statement is get displayed here. This is how the printf statement works with control string support in order to print various input. Let us understand the scanf statement and many other statements which are required for the future in the next class. So with this small introduction, I hope all of you understood how to write your first program very simple way and effective way. Type this program and run this and see the effect. Let us see in the next hour how to read the various types of input through the scanf statement and many other statements which are required to do many computations which are required in the process. Thank you.